Sorry, just get everything set up. We'll get started in just a minute. Okay. Well, good morning. We're currently picking up where we left off on Tuesday, where we have started, where we took some content to which we actually took it from the Department of Justice, We took the sample content, brought down like 150 blog posts. I mean, the number doesn't really matter, just as long as it's a good chunk. And then we brought it down. We read it into our encodings here. And then we actually used one of our models to locally encode the content. So we're using Snowflake Arctic to do the embeddings. And of course, it's a little slow because we're doing it on the laptop. It would go quite a bit more faster if we would use like a third-party, well, a proper model. Well, it's not a proper model, but one that's hosted somewhere else, because it'll run so much more faster, and it would have a GPU to use and all that good jazz. So we're kind of stuck with what we have. I was trying to do it like truly free, as opposed to using my AI, OpenAI tokens or anything like that. So there we are. And it did actually get encoded last time we left. This was taking quite a bit. So, and what's crazy is I did not create the NumPy output for it just yet. That's what this this persist part's going to be. So we're going to cut this number down, and probably offline I'll move it, because I think this took, how long did this take? Once I shut everything down, I guess it didn't take that long. But I don't want you guys just sitting here doing nothing. We'll pick up here in just a second. Let's cut this number down. Let's say, sorry, I hurt my knee, so it's really hard to, it really hurts to just bend it. Okay. I think if I want to slice this, it would be, let's do let's do 10. I think that's right? Yeah, there we go. Okay, and then let's go ahead and write the part to make it persist. Is that not right? I'm pretty sure it's right. Let me double check. Pretty sure it's right in Python. I don't know why it's complaining. But maybe I'm wrong. Let's take a look. Start, stop, no, that seems legit. Well, we'll just see if it yells on the actual, yeah, it doesn't like that. Oh, I didn't actually specify the list. Okay. Mistakes were made. While that's doing that, we're going to start moving down. So yes, we're going to Save the embeddings. This part should be about done. Cut that number on down so we can actually see the progress, because right now I had the batch at 50, so. All right, let's kill this off to see where it's at. Where are you yelling? Argument missing for parameter x in the index add for the index flat IP. There we go. That's one document. 2 documents. The only reason this is slow is because it's on a local machine. And my local machine is currently trying to run OBS. And it's streaming off to Kick, and it's streaming off to YouTube, and it's streaming off to YouTube. And we're playing music. So it is very slow on your local machine. But that's okay. Like, we're here for it. And of course, this laptop, it has no GPU. It's whatever's on board. I think it's like yeah, it's not worth a toot. Oh my goodness, it's taking so long. All right, cool. And so now we should have our embeddings. In the index. And of course, you're not gonna be able to, it's not really useful to us, right? Because it's just only numbers, gibberish, you know. It's NumPy, so. All right, what's next on our list here? Now that we have our encodings. Or embeddings, rather. And we should have our vectors as well. Yeah. All right, so now we actually have to do the clustering and the topic. We do have our index file as well. I forgot about that. Like a NumPy file as well. I'm less familiar with this. Let's see here. Okay. So that is our vectors embedding. All right, cool. So I'm learning this part along with you, so please forgive me. I'm kind of going through and learning. Let's see here. So parquet. Oh, it's just a different format. Okay, so that makes sense. So now we got to take our embeddings. And then we got to convert them. Oh, we don't have to convert them. We have to actually do the clustering on them. So we'll use HDB scan because we actually do want it to auto-discover the topics for us. Actually, I would like to see what this looks like as it is. Let's see here. That's fast. Minimum size, number of samples. leaf size, cluster selection, sources. Actually, good gracious, the parameters on this thing. There's a lot. Hierarchical density-based spatial clustering of applications with noise performs DB scan over variant epsilon values and integrates the result to find clustering that gives the best ability. Okay, let's go to user guide. Sorry, I was reading a couple of things. Can be used extension. Now the other option was to do k-means, but k-means means you know how many groupings you actually want. So if you were like, hey, I want to split this into 10 categories, then you would use k-means. But because we don't know, using HDB scan, we'll let it figure it out on its own. I don't want to plot it, do I? I guess you kind of need to. If we were going to, I mean, that'd be cool to look at. Labels if labels is not none. Probabilities, if probabilities is not none. make blobs. So this is creating dummy data. I already have data, I believe. How do I use it? That's the other question. How do I actually use the vectors that I have? Embeddings. Yeah, I'm not certain. I don't see, none of these show like data being loaded in, right? Like, they're crazy. All right, let's see what ChatGPT's got to say about this. We're driving me nuts. Let's see here. So we're gonna NumPy, UMap, HTTP scan, pairwise, cosine similarity, and load our artifacts. So there's the embeddings that we created. There is the metadata that we loaded, that we have, that we created previous time. Load our embeds, load our metadata. Make sure it has the same number. Okay. Let's see. Well, let's give it a whirl. Let's see what we got going on. I probably bumped this on down to like 5, 2. I only have 10 blocks, right? Because we could. It would take a while. Although I guess I could go ahead and have it running while we're here, doing the other part. Well, let's do it over here. Python. Okay. All right. So let's create from that. Go up. On navigation, 7, 10. Okay. All right, now let's go ahead and create a new file. We'll call it cluster scan. Let's see what got us here. Now we do have these files with doc embeddings, and then the metadata is there as well. Load the files, got that part. Make sure they have the same length, got that part. UMAP helps HDV scan find cleaner clusters and run faster. 15 to 20 DIMMs is a good starting point. All right, I guess the first question is what's a DIMM? Adjust in neighbors to control local global structure. Let's go find out. Oh. There we go with Python reading. Python! All right, UMAP, Uniform Manifold Approximation and Projection for Dimension Reduction. That's a mouthful. I can see why it's an acronym. Could you imagine? Yeah, let's use the uniform manifold approximation projection for dimension reduction. The uniform manifold approximation and projection is a dimension reduction technique. It can be used for visualization similarly to TSNE, but also for general nonlinear dimension reduction. The algorithm is founded on 3 assumptions about the data. The data is uniformly distributed on a Riemannian manifold. The Riemannian metric is locally constant or can be approximated as such, and the manifold is locally connected. I'm not a data scientist, and that's some statistics right there. I don't know. I don't know. If you know, if anyone knows, you know, let me know. From these assumptions, it's possible to model the manifold with a fuzzy topological structure. The embeddings is found when searching for a low-dimensional projection of the data that has the closest possible equivalent fuzzy topological structure. Damn, where's the English version of this? Excuse me. Obviously, we need NumPy. Okay, so we're reading in Penguin data. Okay, we're dropping the nans. Then okay, so it just did the grouping automatically with the value counts on the real data. Right? What is this? I'm not familiar with this. What is PD? PD is Pandocs. Okay, so I'm not familiar with this library, but so far that looks pretty cool. I have to admit, that's pretty neat. You just pull it in, and then you're like, hey, go ahead and give me the groupings, and it's already there. That's a nifty little trick. I like it. Trying to buy us some time here because I feel like we need more data. Like, I know we need more data. We don't have enough data. Probably should have already had the embeddings. Should just let it run last time to have it for us. But here we are. But we're not quite halfway yet. Dimensions. Okay. I only have 10 items, so I don't know how this is going to do. We'll give it a shot, though. I feel like this is not going to work very well for that 10. I have to wait for the 150 at least. Excuse me. Oh. Uh-oh. That's weird. Oh, I can't be resolved. It's probably using Python 2. Maybe? Maybe that's what it's bitching about. I bet you that's what it's doing. Let's take a look. But I know. Yeah, we did HDB scan. Oh, well that's dumb. I see what I did. To silly me. Looks like we're about 4 minutes left on our embeddings. Then we'll have a bigger set. We have 150 to work with. So that seems exciting. Okay. Oh, weird. Oh, because we did leave it at 150 for the yeah. That makes sense. That checks out. That's fair. Although I am curious, what does this look like? Like once we're in, like, what is it? Like, what's the metadata? Please forgive me. I really hurt my knee. I don't know how. I woke up yesterday afternoon and just was in immense pain. And now, like, getting up, sitting down, if I bend it at a 90-degree angle or anything like that, it just is so painful. Okay. Well, that's cool. We got the UID in the title. And then like an index on it. So that's really all it is. Okay. Well, that makes sense. I don't know what I was expecting. I don't know what I was expecting. I really don't. Well, let's look at the embeds. What does that look like? While that's doing that, let's go look up what L2 normalized is. L2 normalization, mathematical process that scales a vector's components so that it's L2 norm. To perform L2 normalization, you square each component of the vector, sum the squares, take the square root of that sum to find the vector's magnitude, and then divide each original component by this magnitude. This process converts the vector into a unit vector, making it useful for tasks where relative magnitudes are more important than absolute values. Oh, okay. Square, put it down. 1. Okay. Gives us a smaller data set. Well, yeah. Yay! So these should match now. We did the full set. Okay, that's making a little bit more sense now. Oh, we're gonna have to log very soon. I'm really sorry. This has been a very, very boring stream. This is very new to me, using it this way. Like I'm much more. Okay. But either way, I've enjoyed hanging out with you guys. Wish I would have made a little bit more progress. But I may just go ahead and uncomment this and let it run and see what happens. Because nothing looks crazy. Let's see. That's up here. Found 3 clusters. Only 3? You know what? Put that down to 5. Let's see what we get. I'm curious, like, what do we do after this? Like, okay, now we have, well, I got a thing to work from, right? But 9 clusters. Okay, that seems a little more in line. Oh, these are summaries. Oh, check that out. Summaries. That did not look like 13. 1, 2, 3. Oh, these are just examples. 1, 2, 3, 3 samples. Recognize domestic violence. Recognizes Domestic Violence Awareness Month. Defending childhood. Education, campus safety, and forward momentum in the Office of Justice Program. ADA. Sorry. Yeah, let's get the cluster. Let's do it. Let's actually get those names. It's trying to use, what is it trying to use? Meta. Which is what we loaded from there, okay. What else does it need? That's too small. So it's using meta and text. So text. Okay, so actually we need to drop this into to run that. Shouldn't take that long. Oh, we gotta add text to the column. Oh crap, okay, so we gotta go back to our... I think I could skip that, so that'll be fine. So we can actually just come in here to our create embeds. And now we got text. Oh, no we don't. So we need text. We need text. So let's not. Let's skip this part. Keep the meta. Yeah, we just want to create the meta. Because all that's doing is, oh, sorry. So we actually didn't write like all of this. We just wrote the metadata because that's all we needed. So that should be good for what we need to actually do the clustering. And so hopefully this go round, we can actually get those categories out of there. Because we created the clusters and we got, how many did we get? Let's see here. Sorry for all the splitting here. Let's see, how many did we get? It was Yeah, 7, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. I don't know why I just counted that, but whatever. And so they gave us some samples. So now, okay, so now we should have some keywords. What do we got? Okay. So the first one is violence, women, domestic violence, and non-breaking space. That's cute. Domestic violence. So, okay, that makes sense. More MBSP. So obviously, they must have some raw HTML in the data. So if, just to give you a little background, the data that we're using is from the Department of Justice. We found blogs from there, and then we pulled down like 150 of them. It's the data that we're using is let's see, data from awesome data sets, because we just needed something, right? Let's see here. So we used awesome data sets, and then we just found some blogs. So we actually just came down here. We were really lazy about it. We just kind of like, okay, blog. Let's see, where did I find it at? Currency, food, gaming, government. Yeah, blog entries. Literally found the first word, first blog, right? And then we just found this, which I was like, it's already JSON format, can totally use it. Hold it down and hey, Bob's your uncle. I'm very curious. Oh yeah, okay, there it is, everywhere. It's all in it. So it makes sense. I mean, there's the keyword. Probably should have stripped that out, but whatever. Somebody didn't grab the new line though, I guess because it's too small. It's too small for what we're doing. So, okay, so we got MBSP, Justice, Crime, Tribal, Enforcement. Tribal, huh? Children, Enforcement, Department, Intellectual Property. That's a weird one. Rights, Attorney, Civil rights. Okay. Fraud, Healthcare, Health and Care, Decisions, Court Decisions, Topics. ADA, Rights, Disability, Civil, and New Department, Agency. And if we actually look at the summary, right? And then we compare this. Hold on, let me move this over a little bit so we can see what we're doing. And we compare this with the. We can see how this makes sense, right? So the example title that we have is the three boxes, and then just department recognized, same, just different time, I guess. And director carbon, and then this one, defending childhood, department education work together to improve campus safety, forward momentum at the office justice department. Strategic plan of intellectual property. And then this one, upcoming conferences. Chief, FOIA. Oh man, what is FOIA again? Federal. Oh man, I should know this. Freedom of information, that's right. change of date for best practices working group. Cool. All right. Well, I hate to kind of cut it off here, but I do have to go wake up the kids now. Thanks for joining me. Sorry I didn't get to see much. I was basically bumbling around trying to figure stuff out. So if you want to see me bumbling around some more, I will probably be doing this tomorrow and or Saturday. Those are possibilities, but I'll definitely be here next Tuesday. And then we're going to continue down this path. We have so now we have our clustering and topic labels. We may circle back and do the k-means because we kind of skipped over the k-means and just went to the HTTP scanning. So I may circle back, and then we'll create the summarization. We probably will not use GPT-4o Mini just because I'm trying to do everything local, which obviously takes longer, but it's all free and everyone has access to it because I'm hoping to pull this together as part of me learning to have some training tools and additional content in general, just kind of do tutorials and kind of walk people through it as I'm learning. So we'll put that together in summarization. Then we'll actually do a search. We'll create a front end search aspect of it, so you can actually see what's going on. All right. Well, anyways, I hope everyone has a wonderful rest of your day. And I will catch you guys tomorrow or Saturday or Tuesday. All right. Thanks again.